In this box right here, this first box, you literally put this function right here, x squared plus 4y squared minus 3xy.
Okay.
And then what was unclear to me, because you actually don't necessarily do this when you're doing the problems, is you actually take this and put it in there, but you might say, well, there's an equal sign. So you actually move everything to one side of the equation.
Okay.
Right. So if you want to, you can write it out like this on your paper. You don't have to, but this is like the full function f, and then we're going to use it to take 3 derivatives, and that's going to be kind of your part 2 on this. Do you see how there's 3 boxes, fx, fy, f lambda below it?
Yeah.
Okay, so fx is going to be 2x minus 3y. This is kind of a review from last time where you're taking the derivative just with respect to x. So if there's an x there, it goes away, just becomes y, minus lambda, and then just the derivative of this with respect to x, which is 1, because all the other stuff goes away. Fy is 8y minus 3x minus lambda. And then again, the only thing in here is derivative with y is that. And then f lambda is minus, so it's just the derivative of this. The derivative of lambda is 1, but it's x plus y minus 48.
Okay.
Okay, and then you set everything equal to 0. So you set this equal to 0, you set this equal to 0, and this last one equal to 0.
Okay.
So it's a pretty straightforward like recipe once you do it once. So this first equation becomes 2x minus 3y equals lambda. You move this lambda over to the other side. The second equation becomes 8y minus 3x equals lambda.
Okay.
And then this last equation becomes, if we move, we distribute the negative and then move a few things around, it becomes x plus y equals 48.
Okay.
And then you set these two equal because you want to get rid of lambda.
Mhm.
So you end up getting 2x minus 3y equals 8y minus 3x. And then you have a system right here of questions that can be solved using any of a variety of methods. Let me just rewrite this first one in a nicer format. So we've got, let's see here, minus x. I'm sorry, 5x, not minus x, 5x, because we're moving that to the other side. And then minus 11y equals 0. And we can solve this system using like matrices or your calculator or whatever.
Okay.
So let me grab my calculator to do this fast and see if we can get a, hopefully I didn't miss any signs here, because that will affect the answer quite a bit, but maybe we got it here. Okay, yeah, we did. So x is 33 and y is 15. It actually worked out nicely. So the method here, if we go back to like what the original like question was or what the intent was, the intent is to use this method to find x and y, and we have done that. So like in short, x is the last ordered pair there.
Mhm.
Let me get this, snip this in. So the last part is 33 comma 15. Right. And then this next box we get from going back to the very original function. We find 33 squared plus 4 times 15 squared minus 3 times 33 times 15.
Okay.
Now, whether it's a max or a min, I will get that next, because I actually have no idea how, if we just go back to the old way of doing it. Yeah, so I don't think there's any like shortcut for finding mins and maxes. I assume this is min or max here. I believe we have to go back and do that analysis we did last time.
Okay.
And let me pull that up here. So that's this this like D value where you have to look at partial derivatives, and let me grab this here. A lot of work here to do these. Okay, so if you recall, you need f of x, fxx, fyy, fxy. So fxx. Okay, if we go back to your function, we have fx, and if you ignore this lambda part, fxx is just 2. fxy, if we go back to our fx, that's the derivative of this with respect to y now, so that's -3. And then fyy, we go back to this line right here, and that's 8. Okay. And then thankfully, these are just nice numbers, so we don't have to evaluate anything, but D is going to be this 2 squared, I'm sorry, 2, just 2, that's fxx, fyy is 8 minus a -3 squared. So this is greater than 0. So that means it's either min or max. Okay, so then we look at the sign of fxx. fxx is greater than 0, so this is a relative min, it looks like. That I guess finishes off. Let me calculate this if you haven't done that already. You get 504 for that.
Okay, yeah, I also got 504.
Okay, so I'm feeling pretty good about the work we did here. I don't see anything that's out of ordinary.
All right. I will send you the next one.
Okay, we don't, and there's no feedback until at the end. Is that right?
Yeah.
Okay. All right. All right, there it is. I'll grab it here. Okay. Yeah, so we're going to use the method of Lagrange multipliers again. So the first thing is to write f of x comma y comma lambda, and that's xy minus lambda times 3x plus y minus 16. You have to move this to the other side of the equation. And then you take 3 derivatives. You take fx, okay, and that's y minus lambda times 3. Fy is x minus lambda times 1. And then f lambda, not z. F lambda is minus 3x plus y minus 16 equals 0.
All right.
So this first one you set equal to 0. And when you do that, you get y equals 3 lambda. And then this next one you set equal to 0 and you get x equals lambda. And then this last one, you actually can move this negative to the other side. Another thing you can do. So you get 3x plus y, and then move the 16 over. So that equals 16. And then because you have x and y in terms of lambda, you're going to substitute this in there. So x is really lambda and y is really 3 lambda.
Okay.
So you get 6 lambda equals 16. You just substitute this in. Let me just show that there and then show this in case you look later. And then you got lambda equals 8/3.
Yes.
Okay, so that's great. X equals lambda, which equals 8/3. And then y equals 3 times 8/3, which is 8. So you have x equals 8/3, y equals 8. And so at the end there, this one doesn't ask for all that intermediate stuff, but it does ask you to like actually get the value of it. So here it is. We have the point 8, 3, 8. And then to find this value right here, we have to substitute that back into the original. So actually, this isn't too bad. It's xy, so it's 8/3 times 8. So that goes in there. So that's whatever, 64/3. Okay. And then to do this last part, we have to do this again, which I never remember. So, I mean, let's get that here. So we need fx, x. So fx, if you go back and look at the notes here, fx was just y. It's got this lambda stuff, but that's going to go away. So fxx is 0, fxy. So that's the derivative of this with respect to y. So that's 1. And then we needed fyy. Fyy is the derivative of this line right here with respect to y. That's also 0. So our d is 0 times 0 minus 1 squared. So it's -1. It's less than 0. So it's a saddle point.
Okay. So.
And I guess that's neither. I don't know what drop down, what the options are here.
Yeah, it says maximum, minimum, and then there's one with like no, it just is blank. So I'll just leave it blank.
Okay. It is odd, but I guess I don't, I mean, we have to go by what this says.
Yeah. Okay. This one seems, the one that I'm just sending you seems pretty simple. Like I don't remember how to do it, but as soon as I do it once, I can do it again.
Well, like you have to tell me, do we need to actually do the multiplier method anymore? Because you don't need to do it for any of these, but if it, if there's boxes there, then do it. So like here again, like this is x plus y equals 26. That's your constraint. So that's usually what comes second. And then you're trying to maximize f of xy equals x times y. Okay, so the answer to this is always the like whatever half of it is. So it's 13 and 13.
Okay.
And I mean, it's the same method to figure out that this is the case. Do you want us to work through the process of finding partial derivatives in Lagrange multiplier?
No, I think these one, like this one I can do on my own. So it would both be 13.
Yes.
13, comma 13. Okay.
Yes.
Yeah, so this unit is like the Lagrange multipliers.
Yes.
And then there's the other two units. I don't think you have to use that method anymore.
Right. Yeah, it's quite a shock when you see this for the first time. So yes, this one we'll just do the method of Lagrange multipliers again. So yeah, so the function you set up, you take this first part and you just write it 3y squared minus 2x squared minus lambda, and then you put this next box underline thing over here to the right, but you subtract whatever that number is. You want everything to be on one side, and you got to take some derivatives here. So fx is minus 4x minus lambda times 3. Fy is 6y minus lambda times 3. And then f lambda is negative 3x plus 2y minus 27 equals 0. Actually set them all equal to 0. Okay, so here, this first line, you get minus 4x equals 3 lambda. And then in the line below it, you get 6y equals 3 lambda. And then this equation here, this last one becomes 3x plus 2y equals 27. Just move some things around. So you solve for x.
Okay.
And solve for y. And you substitute those in there. So like the first one, x equals negative 3/4 lambda. And the second one, y is equal to 1/2 lambda. And we just put those in here. So this is 3 times minus 3/4 x, well, I'm sorry, lambda, plus 2 times 1/2 lambda equals 27.
Okay. That becomes.
So this is 4 lambda over 4 when you make a common denominator. Hopefully this works out nice. So lambda equals 27 times minus 4/5. And that's not really all that important. What's important is the value you get when you throw them back in for x and y.
Okay.
So that doesn't really work out great. Makes me think maybe there's a mistake made, but I'm not sure. And then so we had x equals minus 3/4 times lambda, and y was equal to 1/2 minus 108/5. This is 81/5. This is minus 54/5. So that's your ordered pair. That's the last box.
Okay.
The middle one, we have to actually put those values back in to the original equation. So what did I say here? 81 over 5, comma, minus 54 over 5. Right. And then just gotta be careful putting that back into the original. So I'll do that now on my calculator and see what I come up with. It
So
may end
the
up
original
the
equation
original.
that we're putting it in is that's the 3x squared minus 2x squared minus lambda 3x.
No,
That
just
was
this first one. Yeah.
okay.
All that other stuff's extra.
Oh wow.
Yeah. I'd like to check the work here again, because just lambda sulfur. 3x. Oh, there's a 3 there. That's going to make a big difference. Oh boy. Okay, so that does impact this. It impacts everything we did. So let me carry it through here. There's a 3. So that's 3 halves lambda. That makes it 6 over 4 lambda, which makes that minus 3 over 4 lambda, which makes that a much nicer number. Okay, so lambda is, I think it's just 36. Let me check that. Yeah, so lambda is negative 36, which does make this much different.
Okay.
But we can fix it real quick here. So x is negative 3/4 of negative 36. So that is 27, and y is negative 18.
Okay.
Okay. And then when we try those numbers, we're going to get much nicer output here. So I'm getting minus 486.
Negative 486, you said?
Yeah.
I got that as well.
Okay, now to determine the rest of it, we need to find fxx. So that ends up being minus 4. fxy, which I believe is 0. Let me go back and check. Yeah, and then fyy is the second derivative, which is just 6. So you get negative 4 times 6 minus 0 squared. So this is negative 24, which is less than 0. Let's go back and see what that actually means. It means this is a saddle point. I think fxx times fyy. Let's put this in here. So again, you got to know this table. Negative 4 times 6, yeah, minus 0 squared. Okay, so it looks like it's a saddle point. So that means I guess it's none. Which I don't quite follow, but okay. That's what it says. We'll go with.
Oh, whoops, I accidentally sent you something blank. I didn't mean to do that.
All right, I'll stand by for the next one.
There we go.
Okay, there it is. Okay, so this one is 3 variables, but you can do it the same way that we've been doing it. So you start out by writing this function here. So f of x comma y comma z comma lambda. So it's this function x minus 1. So it's the one without the equal sign, plus y minus 1 squared plus z minus 1 squared minus lambda. And then that's where you grab this constraint. So the constraint always goes to the right of lambda. X plus 5y plus 3z minus 184 equals 0. And this time you have to take fx, fy, fz, and f lambda. So there's 4 derivatives you have to take. So fx derivative, just this one, that's power rule. So it's 2x minus 1 minus lambda. And then the only thing in here with an x in it is the first term. So not too bad. And you're setting this equal to 0. So it's like you'll see that lambda just becomes this 2x minus 1. The next is 2 times y minus 1 for that, minus lambda times 5, that equal to 0. And then z, 2 times z minus 1 minus lambda times 3 equals 0. And the derivative with respect to lambda is just this thing, x plus 5y plus 3z minus 184 equals 0.
Okay.
So this first one, you get 2 times x minus 1 equals lambda. Second one is 2 times y minus 1 equals 5 lambda. Third one is 2 times z minus 1 equals 3 lambda. And then just clean this up a little bit. You get x plus 5y plus 3z equals 184. So we're gonna solve each of these for the variable up here. Like we're gonna solve for x. This one we're gonna solve for y. And this we're gonna solve for z. And we're gonna substitute those in here. So like you can probably see the path. Like you get some for x, substitute in, some for y, substitute in, and z, and then you can find lambda. And once you find lambda, you go back and put it in to find the x value here. Okay, so here, lambda, x equals lambda over 2 plus 1. This one is 5 lambda over 2 plus 1. And then this last one is 3 lambda over 2 plus 1. And then we're going to substitute those in here. So it's lambda over 2 plus 1 plus 5 times 5 lambda over 2 plus 1 plus 3 times 3 lambda over 2 plus 1 equals 184.
Okay.
So now we distribute in. This is 25 lambda over 2 plus 5 plus 9 lambda over 2 plus 3 equals 184. So 1, 5, and 3 makes 9. If we subtract that, that's 175 on the right. And then you got lambda over 2, 25 lambda over 2, that's 26 lambda over 2. And then that's 35 lambda over 2, 35 lambda over 2. And it does look like 175 is divisible by 35. It's 5 and times 2. So lambda ends up equaling 10.
Okay.
Which, I mean, that gives me some confidence to know that like this is correct because it's a nice, decent number.
Mm-hmm.
All right, so if lambda is 10, we go back to our substitutions up here.
Okay.
So x is lambda over 2 plus 1. So that's 10 over 2, 5 plus 1 is 6. Y is 5 lambda over 2 plus 1. So it looks like it's 26. And then z is 3 lambda over 2 plus 1. So it looks like 16. So you're, and we don't even have to check. I mean, we only got one, so you can just go with it.
I got 11 for y.
So 5 over 2 is 50 over 225 plus 1.
Oh, 50. Okay, yes, I see. Sorry, my bad.
Sometimes I make mistakes. Please check me. And I've already made a couple today. So
Okay. Give me 1 second.
is it okay if I step away for 30 seconds to heat up some tea?
Yeah, that's fine.
I'll be right back. All right, I'm back. Are we on to something new?
Yes, I just sent it over.
Lovely. Okay. So is this a new section or is it part of the old one?
It's using like the Lagrange multipliers, but with applications. So it's like technically a new section, but it's like the same thing.
Yeah, it is. Yeah, I mean it's all right. So we'll snip this one in. There are a bunch of calculators on the web to do these by, you know, without touching the actual math. But so we want to minimize the total cost. So a zoo supplier is building a glass wall terrarium whose interior volume is to be 640 feet cubed. Floors wall ceiling. Okay. So the cost is what we're trying to minimize, is the cost. The cost is the amount that it costs for an X, which is, and there's two X's. Well, I'm sorry. There's XY, but there's two of those, and then there's a cost associated with this.
Mhm.
And the floor is $5. Then there is a wall, a YZ, and there's two of those. Okay, and the wall is $4, but there's another wall. There's an XZ wall in the front, and there's two of those, and that's times and that's times 4 as well. Plus, this is getting messy. Is it possible that the only costs are the bottom and the top? It does say walls though. Okay, oh, man. And then there's yeah, then there's so that's it. Sorry, that's everything. this, oh no, we got the ceiling. The ceiling is separate. X, Y. Okay. Oh boy. Okay. I messed this up a little bit. So there is, let me do this differently. The cost is the floor plus the ceiling plus the, we'll say front / back wall
Okay.
plus the side walls. So these are walls and the walls. Okay, and that should do it. So the floor is XY and the floor costs $4. The ceiling is also XY because it's up here, but it's $5, so it's 5XY. The front walls and the back walls, that's XZ because there's really a Z here. So there's 2 of those, and that costs 5 times that. And then your sidewalls are YZ, and there's 2 of those, and they cost $5 also. Okay, now we have this. So this is 9XY plus 10XZ plus 10YZ, and it's constraint. It's subject to the fact that X times Y times Z has to equal 640.
Okay.
All right, so now if we write our like our big F, X comma Y comma Z comma lambda, it's 9XY plus 10XZ plus 10YZ minus lambda XYZ minus 640. Okay, and then we do the same thing we did in the previous problems, except this is much more involved. Okay, so do you want us to do this by hand? Do you want us to calculate, or what would you like to do here?
We can just do it by the calculator.
Okay, let me see if I can find a decent one here. All right, let me see if I can get this one to work. This works. Well, that's not good. It didn't find any. Bless it. Okay. Is there an example problem of this? I just want to, I'm concerned we're not doing this the most efficient way.
Yes.
I guess I can also check Chegg and see what they say for this.
Yeah, I think I'm probably just after this tutoring session going to drop the class because it just is not convenient for me.
Okay. It does, again, I'll just say, and it does get better. It's taught the same way every time, although I mean, it's kind of at the instructor's discretion whether they do do it this way. Like they don't have to make it this hard, I guess is what I was trying to say.
Yeah, I'll probably just like take a summer like at the Rio de Janeiro or whatever.
Yeah, and that's another option where they don't, you don't you do something easier at another other college. But is there give me just another moment here to figure this out. The first calculator didn't give me anything useful. So
Yeah, I'm looking to see. And then I think I signed up for a tutoring session after
yes,
this. Is there any way that we can just like cancel that?
I can give you a credit for like 30 days if you want to use it
That's perfect.
on something else.
Yeah.
And you just tell me when you want to use it.
Okay.
I'll reschedule you. All right. Find it. Okay.
Okay.
So they actually solved this. They actually solved this first one for Z, and then they make it kind of nice. They substitute the other one in, and then they take partial derivatives. Yeah. Is there another problem you'd like to look at before we close out the session?
I think that's really it.
Okay. Well, thank you. Thank you for scheduling. And yeah, just let me know when you want to use that next session.
All right. Thank you.
Have a great day. Bye now.
Bye.